Okay, so today's tutorial is going to be based and inspired by David Brodeurs' work, Locked and Loading. It's worth having a follow. His organic textures and animations are fantastic. So let's have a look at how we can do this in Cinema 4D. I'm going to go quite quick and assume you've got a certain amount of knowledge already. So this is what our target is for this first lesson here. Let's just get the geometry correct first of all. So first of all, I'm going to generate a spline around which we're going to just place a lathe onto the stage, and then we need to alter the subdivisions to make sure they're nice and even. So we're going to change the subdivision of the spline and the subdivision of the lathe so you've got a nice even mesh. We then need some cylinders, so I'm going to create a couple of cylinders here. We're going to use these to create the holes. They're going to live inside a MoGraph. So the cylinders are nice and small, radius of 4 and 5 on there. So now we want a MoGraph to place these into. So there's our cloner. We place both the cylinders inside the cloner. We make sure that they're mapped onto the object, of course. So we make sure that the lathe nerve is the object that the cloner is mapping onto. So now we've got these cylinders, they're going to be distributed across the whole lot. So what we need to do is we need to create a selection. So once you've got a selection on the lathe nerve, as you can see, I've got the lathe nerve there, we've got a selection. We can tell the cloner to limit the clones to just that selection on the lathe nerve, and that way we'll get some holes knocked out of this bad boy. So take the cloner and where it says selection down here, drag and drop the selection into there. You'll notice I've switched off the cylinders just at the moment. I'm just going to switch them back on again. There you go, and you can see the problem with distribution straight away. So we need to go into the cloner and change distribution to polygon center. Right. Okay, so now we need to create a Boolean to knock the objects out one from another. So we'll drop both of those straight into the Boolean. The order here is going to be important, otherwise it's not going to work. And in the Boolean we need to change it to A without B and switch on hide new edges just to keep it a little bit tidier. Now I'm going to create a random effector so that we can randomize the size of the holes. So I'm going to switch off the position setting and switch the scale setting on so the holes are random size and dimensions. We'll group the objects together. Put a name. So that's our original setup, and we're going to now duplicate the original lathe nerve that we created. So that's going to be the inner collider body for the stretched material that we're going to create in a moment, and then we're going to make the current state to object and extract that lathe nerve now with the holes in it. So we've now got the original lathe and we've got a lathe with holes in it. So we've got our inner and outer surface which we're going to have stretched one over across the top of the other. But at the moment they're both occupying the same space. So now we need to change the outer. I'm just going to name it. Change the outer so that it's slightly offset from the inner, and we're going to use the cloth material to stretch the outer honeycomb over the inner collider body. Okay, so next thing we need to sort out is the normals. As you can see on the collider object at the moment, the normals are facing the wrong way. They're all facing in, and when it comes to setting up the cloth it's going to have issues. So I'm just going to hit reverse normals on that so all the normals are facing in the right way. So that's the collider sorted. We're going to apply a simulation tag. It's going to be the collider, which we're going to stretch over the top, and we're going to put a bounce of 0 on that. Now we really need to deselect all of these, so I'm just going to hit deselect all. Okay, so that's the inner collider setup. I'm going to make that invisible, and I'm now going to switch back on the outer honeycomb, and you can see again that the normals is an issue here, so I'm going to do a select all, and we're going to do a reverse normals on this. So this is our outer honeycomb, which we created from the Boolean operation earlier on. So normals, reverse normals. You can also do an align normals as well if you need to, just to make sure that everything's facing the correct way. Okay, we're going to go back to the inner collider now, and we need to make that a slightly different size to the outer because they're still occupying the same space. So to get one to shrink wrap literally onto another, we need to make the inner one slightly smaller. So I'm going to get the normal move and just drag it down slightly so that it's slightly smaller than the outer. You can now see that the inner collider is slightly smaller than the outer. This is the key to getting this to work. Okay, I'm now going to select the outer, and we need to add a cloth tag. We need the cloth NURBS tag here, so let's get the cloth NURBS tag, and the outer needs to be a child of the cloth NURB. I'm just going to deselect all the faces to make sure that it's not so confusing. Okay, so there you go. You've now got the cloth NURB applied, and we need to change the settings for the cloth NURBS. So I'm going to go in and remove these subdivisions because the hyper NURBS will give us the subdivisions that we want, but we do need thickness on the cloth NURBS so you can see what's going on. So there you go, we're starting to get somewhere now. Okay. Now we also need a tag applied to this outer. So we're going to get the simulation tag, cloth tag, and we're going to need to change some settings on this to get this to work. So first of all, we don't want gravity, we don't want this falling off. We're going to be shrink wrapping it to the original. So remove all the forces, and here's where it makes all the difference as to these settings here. You'll find some settings work for you, some don't, but I'm going to reduce the stiffness, increase the rubber up to 100%. We don't want bounce on there either, so I'm going to bang that down. And the important one here is the size as well. So the size here, we're going to shrink wrap it, so it's going to be reducing size. So by setting this down below 50, say to about 30%, and then running it. So we want to run it on the timeline here. So we need to increase how long the timeline is because 90 frames isn't going to be enough to run the simulation. So it's dynamic simulation. It won't work unless you hit the play button. Now it's going to go a little bit crazy here, but once it settles down, you'll find we've got a really nice geometry on our mesh, and we get a lovely spiderwebbed feel, stretched material to it. So we're going to run about 100 frames. You can run it to 200. You could do various things with it. There you go. It's stretching it really nicely now. I'll stop it and rotate it around, and we'll see what we got. There we have it. Very nice. Looks like a spider's dinner. That's what we're after. Okay, so the next operation, we need to smooth out this mesh because it's a little bit rough around the edges. So we're going to create a hyper NURBS object and drop our cloth NURBS inside it. I'm now going to change all that to an editable object as well, while keeping the original. So we've got the original of the outer comb and I'm going to hide that away as well just for the moment, so we've got the original as a reference. So now we've got an outer cone that's an editable mesh, and as you can see it's quite a high res poly, and here's our inner mesh as well, and we need to get the two to intersect, and at the moment they don't intersect. One's a lot smaller than the other, so I'm going to duplicate the inner collider, and we're going to rename that. So this is an intersection, and the outer one, that's an intersection as well. And what we're going to do here is we're going to duplicate it and rename it intersection 2. So we've now got a copy of both our inner mesh and our outer mesh, and as you can see the polys are a bit high. Considering I want to do a Boolean operation on this, it's going to have trouble with that many polys. So I'm just going to apply to the outer intersection a poly reduction. So if you see, I've got a reduction of strength of 90%. The bottom left hand corner now, you've got this reducing polygon now, so it's now taking that smoothed polygon now and just reducing the count as well. So we've now got a smooth outer mesh with as few polys as we can get away with. So now we're done with that, we can do a current state to object, because I don't want to use that in my Boolean operation. It will make the Boolean operation go very slow, and you can see as I'm converting it, it's reducing again down the bottom left hand corner. So now we've got an editable version of that. I can delete that. So now I've got intersection 2. So you can see the poly count for that has come down. I'm just going to deselect all of these. So intersection 1, intersection 2, those are the two things that I need to go into my Boolean operator to get the intersections between the two to fill these pools up. So we create a Boolean, and inside that Boolean now we're going to put both of these new meshes that we created. Remember, this is just to fill in the pools. So we now need to change the Boolean operator, a without b, and also we need select intersection switched on as well. So the reason why we're not getting anything at the moment is because they don't intersect. The inner one is slightly smaller than the outer, so we need to expand the inner intersection. So what I'm going to do is I'm going to looking for the normals here. Normal move. There's normal move. Yeah, we already got it. Okay, so we got normal move there. That's it. So if we do a normal move on there, it might be an idea if I just switch off. That's better. Right. Okay. If I normal move now, I can see to get an intersection, and you'll see where I'm going with this. So as I enlarge it, we get an intersection. Not too much. There we go. We've now got an intersection, and that's going to sort of be where our pools are. Okay, so we've now, that's pretty cool. Checking from all different views to make sure it's working. So each of these is going to be individual pools, maybe of magma or plasma or something like that, and we're going to animate them further down the line. So now that's working, we need right, so what we're looking for is the edges here, and the way we're going to get the edges is I'm going to convert this into from current state to an editable object, and if I select this new object that we just created from the Boolean here, the faces are still selected all here, but we're after the edges so that we can then create some splines from the edges. So I'm just going to deselect all. Here we go. So now you can see we've got edges there, and those are going to be used to do an edge to spline operation in a moment. So I can now hide that Boolean operator because that's now done its job, so I'm just going to switch them both off there. So we've now got an intersection between, well, we've got the edges of the pool, I suppose. I'm just going to give this a name so that we know that we've got that one stored away. So now we're ready for the next section. We've got these edges and we can now do an edge to spline. So we now go to edge to spline. That will appear below the Boolean that we created there. I can pull that out now, you don't need it as a child anymore. We can get rid of the Boolean now, that's served its purpose. So now we've got a spline, that's what I was after. At the start of this, we've now got a defined edge, and we can now mess about with that and create little pools, and some of them will be animated and some of them won't. So that's the next stage. Right, okay, so the next stage is to use an extrude, and we're going to set this movement to 0. And the reason why it's not showing is we need to select intermediate points to natural because it's automatically coming in as none. And you can see it's a little bit messy. You're always going to get a little bit of an issue with this. It's going to need a bit of tidying up. So what I'm going to also do is change the caps. I'd like a regular grid because when it comes to animating this further down the line, we need a better mesh. So if we go to quadrangles, regular grid, that gives us a better mesh to animate because these are going to inflate and deflate individually. So that makes it a little bit easier to work with, and you will see nice distortions. We've still got a bit of an issue at the top here. What we're going to do is probably just delete some of these points. I mean, obviously if I was doing this properly I'd spend a little bit more time getting these right, but this is just to give you an idea, a starting point. Careful of the intersections as well. Sometimes they tend to overlap a little bit and cause all sorts of problems, but most of these look okay. Yeah, that'll do for the moment. It gives you an idea, gives you something to work with. So these are our pool areas, and we could do with renaming that. Okay, that's our pools. And we can switch the outer back on again. Incidentally, you'll notice I've left all the cloth tags on and stuff. You could actually be removing those as well while you're going along just to keep things neat, but what I'm going to do is just apply a material now to the pools just so you can see how it shows up, and drop that onto there. There we go. So that gives you the idea of how it's looking. There you go. So that's part 1 basically. We've got our structure and our form. And next lesson what we'll do is we'll start applying some light materials to it, and I'll also start animating these pools so that they inflate and deflate as per the original. I hope you've enjoyed that, and look forward to seeing you again. Thank you.